You are living through a structural transformation in how enterprises operate. Artificial intelligence is no longer an innovation project. It is no longer a proof of concept running quietly inside a research team. It is becoming foundational to how modern organizations function. Enterprises are no longer simply using artificial intelligence to improve a few processes. They are redesigning themselves around it. Decision making, automation, forecasting, product development, customer engagement, compliance analysis, software development, and even executive strategy are increasingly influenced by artificial intelligence systems. This is what defines an artificial intelligence native enterprise. An artificial intelligence native enterprise does not treat artificial intelligence as a feature. It treats it as infrastructure. And when something becomes infrastructure, security must evolve with it. As a leader or architect, you must recognize that this transformation is not incremental. It is architectural. In earlier technology shifts, new capabilities were layered onto existing systems. Mobile applications were built on top of web services. Cloud computing extended traditional data centers. Even digital transformation initiatives often enhance existing workflows rather than redefining them. Artificial intelligence is fundamentally different. Artificial intelligence is not merely adding functionality. It is changing how decisions are made. It is changing how data is interpreted. It is changing how systems behave. When a customer support platform is powered by artificial intelligence, it is not just answering questions. It is shaping customer perception of your brand. When finance teams rely on artificial intelligence to forecast trends, it is influencing capital allocation. When developers use artificial intelligence to generate software code, it is affecting the integrity of the software supply chain. Artificial intelligence is becoming embedded in enterprise resource planning systems, legal drafting tools, compliance analysis platforms, procurement systems, cybersecurity monitoring systems, and executive dashboards. You are no longer protecting static applications. You are protecting intelligent decision systems. When artificial intelligence becomes a foundational layer, it must be secured with the same rigor as identity systems, data platforms, and network architecture. Artificial intelligence is horizontal. It does not remain confined to one department. Human resources use artificial intelligence to screen resumes and analyze workforce data. Finance teams use artificial intelligence to detect anomalies and project financial performance. Marketing teams use artificial intelligence to generate campaigns and personalize customer engagement. Legal teams use artificial intelligence to draft contracts and analyze regulatory obligations. Software development teams use artificial intelligence to write and review code. Executives use artificial intelligence for strategic insight and decision support. When artificial intelligence touches every workflow, the exposure multiplies. A vulnerability in an isolated system is a problem. A vulnerability in a system embedded across the enterprise is a strategic risk. If an artificial intelligence model generates biased outputs in recruitment, your organization faces reputational and legal consequences. If an artificial intelligence assistant exposes sensitive financial information through manipulated input, you face regulatory exposure. If artificial intelligence generated code introduces insecure logic, downstream systems inherit that vulnerability. Security must evolve because artificial intelligence is expanding influence across every layer of enterprise operations. Why traditional application security is not enough? You are familiar with traditional application security. You understand code reviews, input validation, secure development lifecycle practices, encryption, identity management, and access control. These practices remain important. However, they were designed for deterministic software. Deterministic software executes predefined instructions. If you provide a specific input, you expect a predictable output. Security weaknesses typically arise from coding errors, configuration flaws, or infrastructure misconfigurations. Artificial intelligence systems do not operate deterministically. They operate probabilistically. They generate responses based on patterns learned from data. Their behavior can be influenced by context, training material, and subtle manipulation. Traditional application security does not address prompt manipulation that changes system behavior, model extraction attempts that steal intellectual property, data poisoning that influences model outcomes, retrieval manipulation that inserts malicious content into knowledge systems, inference attacks that expose sensitive information, autonomous execution misuse where intelligent agents perform unintended actions. You may secure the application interface while failing to secure the reasoning layer. You may protect the database while leaving retrieval pipelines exposed. You may enforce authentication but fail to isolate contextual prompts. Traditional controls alone cannot secure intelligent systems. Artificial intelligence security requires new architectural patterns layered on top of existing controls. When you deploy artificial intelligence systems, you introduce new architectural components. Training data pipelines, model weights representing intellectual property, embedding stores that index enterprise knowledge, retrieval systems that dynamically access information, prompt construction logic, external artificial intelligence service providers, autonomous agents capable of executing actions. Each component introduces risk. Training data may contain sensitive information or biased content. If manipulated, it can alter model behavior. Model weights may be targeted for extraction, resulting in intellectual property loss. Embedding databases may expose internal knowledge if improperly segmented. Retrieval systems may incorporate malicious documents that influence responses. Autonomous agents may execute actions beyond intended scope if guardrails are insufficient. Consider a scenario where an attacker inserts misleading content into a document repository that feeds your artificial intelligence retrieval system. The model retrieves that content and presents manipulated insights to decision makers. No firewall was breached. No malicious code was executed. Yet the integrity of your decision process has been compromised. This is a fundamentally new threat landscape. Artificial intelligence systems are attractive targets. They contain intellectual property. They influence decisions. They access sensitive information. At the same time, adversaries use artificial intelligence to enhance their attacks. Artificial intelligence can generate highly convincing phishing messages. It can automate reconnaissance. It can produce malicious code at scale. This creates a dynamic threat environment where intelligence systems are both under attack and enabling attack. If your enterprise integrates artificial intelligence without embedding security architecture, you risk amplifying exposure while simultaneously empowering adversaries. Security must evolve not only to protect artificial intelligence systems, but also to defend against artificial intelligence-enabled threats. As a leader or architect, you must think beyond technical compromise. You must evaluate business impact. Insecure artificial intelligence can result in reputational damage if systems generate harmful or biased outputs. It can result in regulatory penalties if decisions violate privacy or transparency obligations. It can result in intellectual property loss if proprietary models are extracted. It can result in operational disruption if automated processes behave unpredictably. It can result in loss of customer trust if sensitive information is exposed. Imagine an internal artificial intelligence assistant that unintentionally reveals confidential payroll information due to insufficient contextual isolation. The technical flaw may be subtle. The public and regulatory consequences could be severe. Imagine a generative system used in marketing that produces misleading claims, because of manipulated input. Legal exposure becomes immediate. These risks are real and they scale with adoption. In previous eras, security architecture focused primarily on protecting infrastructure, networks, endpoints, applications, databases, identity systems. In an artificial intelligence native enterprise, you must also protect intelligence integrity. You must ensure the integrity of training data, the integrity of model behavior, the integrity of retrieval sources, the integrity of automated decisions, the integrity of generated outputs. Artificial intelligence systems influence enterprise judgment. Protecting them is equivalent to protecting executive reasoning. This requires architectural evolution, guardrail patterns embedded in design, role-based retrieval controls, human oversight mechanisms, continuous output monitoring, validation of reasoning pathways. Security must move upstream into design and downstream into continuous evaluation. Artificial intelligence will not remain optional. It will be embedded in enterprise resource planning systems, in cybersecurity platforms, in compliance monitoring engines, in supply chain systems, in board-level reporting tools. Executives will demand assurance that artificial intelligence systems are secure. Regulators will demand transparency and documentation. Customers will expect responsible artificial intelligence practices. Investors will evaluate governance maturity. The demand for artificial intelligence security architecture will increase precisely because artificial intelligence will be invisible infrastructure. You have a choice. You can react to incidents, or you can design secure foundations. Organizations that embed artificial intelligence security architecture early will innovate confidently. Those that delay will operate under constant risk of breach, scandal, and regulatory scrutiny. Every major technological shift created new architectural disciplines. Cloud security architecture emerged. Zero trust architecture evolved. Secure software supply chain design became essential. Now, artificial intelligence security architecture is emerging as its own discipline. You have the opportunity to define reference models, standard integration patterns, risk classification frameworks, governance alignment mechanisms, monitoring and assurance processes. You are not blocking innovation. You are enabling sustainable innovation. By evolving security architecture now, you ensure that artificial intelligence strengthens your enterprise rather than undermining it. Artificial intelligence is becoming core infrastructure, not merely a feature. Traditional application security is necessary but insufficient for intelligence systems. The attack surface of artificial intelligence systems is broader and more dynamic. Insecure artificial intelligence introduces strategic business risk. Artificial intelligence will be embedded into every enterprise workflow. Security architecture must evolve to protect intelligence systems, not only infrastructure. You must take leadership in defining this discipline. If this session has expanded your perspective, then you are ready to lead in this new era. In this course, you will explore artificial intelligence threat modeling, security reference architectures, governance integration, retrieval security, red teaming, and securing autonomous intelligence systems. Subscribe to the channel so you do not miss the upcoming lectures. Like this video if you believe artificial intelligence security architecture will define the next decade of enterprise design. And share your thoughts in the comments. How is artificial intelligence being integrated within your organization today? Are you shaping secure foundations or reacting to rapid adoption? Let us build secure artificial intelligence native enterprises together.